All right, thanks everybody for coming to this session. It's hello, is it me you're looking for? I kind of went back and forth with the beginning slide and decided to go with this one instead of this one. But I thought, you probably had a long night. It's still early in the morning. A nice soothing voice. Start out very well today. But to introduce myself and to stop Lionel. My name is Daniel Egan. I'm a technical evangelist at Microsoft. I've been doing it for about 9 years, and I've been spending a lot of time in both cognitive services, the bot framework, whole conversation as a platform thing. And with me?
Hi, I'm Adnan Masood. I'm the Chief Architect for AI and Machine Learning at UST Global. My PhD is in machine learning, and I'm trying to build an army of cyborgs. The last part is not true.
So we're planning to have a lot of fun today. We have 3 really cool demos to show you today. But we want to start out by talking about, not Lionel again, I'll skip by that, what cognitive services is. If you were in the keynote this morning, like I'm sure many of you were, cognitive services is something that is not one thing. It's many things. It's a suite of APIs that you as developers can use. And we're going to look at a few of those today. And they're broken up into different sections, from vision to speech, language processing, knowledge, and search. And one of the things we're going to do is spend a lot of time in vision and speech today for the stuff we're going to show you.
So one of the key things about cognitive services is that when you go back to work on Monday, how can you start working with AI? That's one of the challenges people usually encounter, and they're like, so how can I start using artificial intelligence and machine learning without a PhD in my work, daily work?
Because I don't have one. He does. Are there any other PhDs in the audience?
So the challenge is, like, how do you do that without knowing the internals of algorithms? So think about, Microsoft has been trying to work on this idea of democratization of AI and has taken leaps and bounds in this effort. So the democratization of AI, the idea is that any developer can take these APIs and start implementing them. Today, when we are using .NET Framework, we don't really think about what sorting algorithm is going behind the scenes. Like, it could be bubble sort for all it matters. But we don't think about this. So similarly, in this case, the APIs, if you want to build an application and want to integrate the vision capabilities or speech capabilities, and you will see in our demos, in your application, and how would you be able to do it without as much knowledge to the underlying code? I mean, it's all open for you. Most of these papers are published on Microsoft Research, and you can see the underlying algorithms underneath it. But it's available for you to be able to consume in an API manner, and we will go through the demos to show you.
Yeah, and cognitive services is a small piece in the whole suite of stuff we have. All from data ingestion to machine learning, obviously visualizing the data you're getting, with Power BI, and then in the intelligence section you have Cortana, cognitive services, and the bot framework. That really, what I actually call, especially cognitive services, developer candy. It's really accessible and adds really cool features. Now, one of the things that makes it so powerful is it's really, really accessible. You can access it via REST, of course, but there's APIs if you're doing Android, if you're doing Apple, if you're doing JavaScript, obviously, if you're doing Python, if you're doing Node, if you're doing C#, of course. So whatever your language of choice is, it's a good chance that you can access them easily through an API. And then, of course, REST if your language of choice is not supported. One of the key things, and this is to me the most powerful part of this, in my job, one of the things I do is go to hackathons. We do a lot of university hackathons all over the country. And the cool thing about cognitive services, and this applies to you as well if you're not doing hackathons in universities, is it's so additive. It doesn't matter what your industry is. It doesn't matter what your application is. It's something you can just add. A lot of times you go to talks and you're like, oh, that's really cool, but we've had this app for 5 years. I can't really just scrap it and start over. All the stuff in cognitive services can be added to the stuff you already have, even if it's VB Script or ASP Classic or anything. It doesn't matter what your app does. You can use this stuff to add to it.
So applications for these APIs are so vast, you probably can come up with a business use case within your enterprise. Think of it as the simplest of a use case as OCR. right? Most of the companies who are dealing with PDFs or printed forms or some sort of text, optical character recognition is a classical problem. Now, traditional OCR applications, I mean, you don't have to buy like a $1,000 license or $10,000 license to get that implemented. You can easily do that with Cognitive API, and there's, I think, a demo for that to show how you can actually do text classification and recognition in there.
And so one of the things that is useful to you is if you think about AI, if you think about machine learning, one of the things that it needs is lots and lots of data, right? And Microsoft as a company has lots of data. It ingests tons of data. If you think about just alone the stuff that comes through Bing, right? And so the power that we can get using the algorithms on that data is something that now you get. It's not something that just for us to use. You're able to use that for the power of your application. And I think that's not just the ones we're talking about, that's underlying all of our AI and all of our cognitive services is this machine learning layer with tons and tons of data under it. So, like I said, it's really, really easy to use. You can just go to Azure, you get a key, and then you make a simple REST call, or you use the API to make the call. So adding this to your application is as simple as those couple lines of code and doing a get or post or whatever you need to do for it. So if we look at cognitive services as a whole, you can see that, like you said, it's broken down into vision and speech and knowledge, language. And these are the things that fall under it. If we look at vision, we have computer vision API, which is something we're going to dive deeper into. We have face API we're going to dive deeper into. And then there's some other ones. Did you want to talk about the emotion or any of the other ones?
So regarding computer vision, there are so many different use cases where we can apply this, from figuring it out if a person who is looking at your merchandise is a passive shopper. How does he like your merchandise? How does he see that? We have, I'm a Microsoft MVP, and I get to talk to a lot of businesses and customers who are actually applying these technologies in real world. So for computer vision aspect, people have applied this to detecting the sentiment analysis, applying the facial recognition and applying sentiment analysis, which I think there's the demo for this. We'll talk about this in detail. And also, an interesting use case is when you can actually figure out the emotion for a person and then see how he reacts to a specific environment and a specific product. So that's a great use case for computer vision API.
So in the demos today, we're going to concentrate on these three, the computer vision, the face API, and the custom vision service. And then when we dive into the speech, we're going to talk about the speaker recognition API. Let's talk about analyzing images themselves. So if we look at this picture, you can see this perfectly taken picture of a man swimming underwater. You can see it gives you a bunch of information when you use the API coming back. You have a rectangle around his face, and we'll dive a little deeper in the face API, but it gives you his relative age. I like the age that comes back for me because it's always much younger. Not everyone likes the age that comes back, but what it does is it's not exact, but it gives you a range of things. So if you think of taking faces of a lot of people coming in a club or at an event or things like that, you can get a relative gauge of the type of people that are there.
One of the good use cases for our business use cases is the gentleman over here wants to build the best Instagram internally for his company, but he still doesn't want the coworker. One guy would upload a racy picture or some inappropriate material, and this will get everybody in trouble. So how can you apply that? So this API, out of the box, you don't have to create your own filter for inappropriate material. It automatically provides you that capability. It will classify and it will tell you the adult scoring. So you can add a threshold, and instead of you looking at the different shades of the body color, it will automatically be able to give you that confidence interval, which you can use to apply. Like if something is over 50%, then not use that or tag that image for a manual supervision.
And that saves you time. Normally what you would have had to do in the past is you would have a team of people that would triage these images, approve them manually. And you'd still probably have to do that, but with a smaller set. You know, you take the threshold that you have, and then there's some that are maybe in that pool of, we may need to have someone, you know, physically look at these. It saves you time, it saves you money, and it allows you to add another feature to your app that maybe wasn't there. Here's another example of stuff coming back. Let me fill that out. And so when you make a call to the service, this is all the data that comes back. You can see that it sees that it's an animal, it sees grass, it sees outdoor, it sees a cow. One of the things that I like, I'm not sure if you guys can read that bottom line. Can you see what that says? It says staring. I love that it knows the cow is staring at you. And then also on the bottom, it will help you try to describe it as well. A brown cow standing on top of a lush green field.
So natural language generation out of this, or dense captioning, are really amazing use cases for artificial intelligence and machine learning. I use these alternatively, and I don't want to get hate mail. So if you have any questions around this, we can talk about this, the implementation of artificial intelligence and machine learning. And machine learning is essentially by far the largest implementation aspect of AI. We are not talking about artificial general intelligence. In this case, a great use case comes to mind from business perspective. There's this country which had a regulation passed that every time someone comes up and starts smoking on the screen in a movie or in a TV show or something, there needs to be a warning at the bottom which says smoking is injurious to health. Now that was a federal regulation, and they had to apply it not only to the future ones but also the previous data set which they had. Like, for example, if they're playing a movie from 10 years, 20 years ago, they had to do this. So there are two ways. Either somebody sits there, goes through millions and millions of minutes of footage, and then puts that text at the bottom, or you can use Vision API. And we were successfully able to demonstrate how the computer vision API can actually detect a person smoking and the presence of the cigarette, and then be able to identify that segment. So now your data set is much smaller. People can just go through this and then identify those and then put those labels on this, the warning symbols. So this is a case where humans don't scale that well. But because, of course, your computer vision APIs can do video indexing and can identify items within a scene, and you can see that information and be able to make decisions based on that. So, of course, this is one of the use cases where cigarette warning, but you can think of tons of different use cases when a specific product is being shown. And I
thought of a very specific one.
All right.
So I always like to take technology and make it personal to me. And so what I did is my wife was very nice to me, and she allowed me to dig a very big hole in my backyard. I always wanted a fish pond. It's not that huge, but you know, like 4 feet deep and 4 feet wide. Put some goldfish in there because they're nice and hardy. What I didn't realize, though, was I wasn't building a fish pond. I was building a raccoon feeder. And so my thought was, why don't I build something to take care of the problem? Now, the first thing I did was buy one of those sprinklers that when it senses motion, it'll sprinkle, right? But I have 2 little kids, so guess what happens? You know, they run around in the yard too. That doesn't work. So what I decided to do was build it using a Raspberry Pi. There's a night vision camera. There's a motion detector. And then there's a switcher circuit that will turn on or turn off the solenoid that will spray water. So basically what happens is I'll take a picture. If I see movement, I'll take that picture, I'll send it up to Cognitive Services, and up in Cognitive Services, it'll send it back down. If it sees a raccoon in it, I'll spray water at it, right? Sounds like something easy to do. So let me show you the code for that first. Actually, let me show you this picture. This is what it actually looks like in the backyard. You can see that I hit it in the plant. This is the first version. I'll show you on screen the latest version of it. But you can see I have it pointing in the background right at the pond, and just have it sticking in a pot. I just bought a little plastic tub at the hardware store and stuck everything in there. We got a little more fancy later, but this is what it looks like. But let me show you the code. This code is actually relatively simple. This one's written in Node. And there's 2 projects in here, Waccoon Camera and Waccoon Device. These other ones are fun things, but it really is just those 2. And if we look at the camera one, make sure I'm looking at the right. Yep. You can see it's very, very simple. The one thing I'm doing here is we tried this both on an Edison and a Raspberry Pi. So this thing on the bottom is reading some information that's on the device to tell me if it's a Raspberry Pi or if it's an Edison. And then all I'm doing is using NPM package called RaspiCam to take a picture. You can see that I'm setting that as a PNG and the rotation and whether the sun's out, height, width, etc. And then for the Edison, it's the same thing, except it doesn't have RaspiCam, so I have to use FFmpeg to do it. But same thing. So all this is doing is taking a picture. This is a little different than the motion one. What this one's doing is it takes a picture, it takes another, and then you'll see in the device I'll show you it's comparing the two if there's any difference in it. Then it'll send it up to Cog Services, but the same concept. So that's the camera one. If we look at the device one, there is two files in here, the index.ts and the store.ts. And I won't go through all of this line by line or anything. We're setting threshold for the differences between the picture and setting where we're going to save the image. We realized a lot of times we had the camera thing running and didn't realize it was running. So this is just cleaning the folders. If there are any images in there when it starts, let's delete them all. And then down here, this is the sensor. If we have a sensor in it, that's the sensor information. And then down here, it's just grabbing the photo. It's determining whether it's within a different variance or not. And if it is, it says match. And when it does match, we're going to go ahead and call this method called store.cog. We're also doing things like sending it to Event Hub. We're doing things like saving the image in blob storage, so if it catches a raccoon, we can show it on a website, stuff like that. But if we look at store, all we're doing is, you can see that what I had on the screen before, you can see I have the URL, and then I have the subscription key that I got from Azure to send it up there. And then I just take a file stream. I'm actually telling it, first of all, what tags I need. So you notice that it gave us a ton of information on that screen that you show with the cow. But you need to tell it all the different types of tags you want. So I'm identifying the tags that I want.
So this is really beautiful. Just a quick thing, if you go up a little bit. So you can actually do all of this just from like your Postman or Newman, right, to the console. So you don't need Node script or anything. Yeah, it's a RESTful API. You can do GET requests. You can do POST requests right there. And then you pass in the subscription key or training key or prediction key, depending on what you're doing. And it will give you the response. How many raccoons did you catch, Daniel?
3.
3.
Yeah, it didn't catch. I squirted and got rid of them.
All right.
And then there's cats and there's other things because I told it to look for a bunch of different things. But you can see I'm sending up the file stream. And then down here, where is it? Actually, I think it's in the other one.
But no raccoon was harmed in making of this demo.
No, exactly. That's what I want to show you right there. If it finds one, it's not only going to shoot it, but then I'm going to put it down on screen. And for this, I had to use a Python script that would turn it on and off. But you can see then if I find a raccoon. So let's go ahead and start this up. And that's what the project looks like. I can bring this back up in a minute. Let me run it. There we go. So I'm actually SSH'd into it. I'm in the camera directory here, so we're going to just start running that. Node. And that'll get running. And then same thing down here for the device. Now, what would be really cool is if I had a raccoon to use for this. And so we're kind of thinking what I can do. But I didn't think you guys would allow me to have a raccoon in here. So I'm not sure what exactly we're going to do.
I wonder. Oh, wow.
We found a raccoon. So let's see what it says when he goes in front of it. I have a little screen here. You'll be able to see what it comes back with the data. I'm not sure if this will work. I don't know if he needs to actually make the sounds. Wait, so there we go. Black, white, mammal. It's got mammal. Dog, it thinks it's a dog. We'll try one more with him. The mask usually doesn't work, I'll tell you that. I've tried it many times. Man staring. See, now he's staring at the camera. So let's thank the raccoon. And I know this works. So there's a picture of a raccoon. Thank you, Jeremy.
Thank you, Jeremy.
And let's see if we can get this to go. We won't spend too much time, but this picture usually will work for it.
Yeah. It did recognize that. You have the ASCII character up there.
Oh, it did it?
Yeah, it did.
Oh, yeah, see?
So
it found the raccoon, and it would have scored it at it. For some of the presentations, I have this really loud horn instead, but people hate it, so I turned it off for you guys. So that was my use of cognitive services. Let me shut this down.
And again, no raccoon was harmed during this demo.
Except for Jeremy's ego a little bit, maybe.
Thank you, Jeremy.
So I think one of the things with what we just showed you there is those are the models that are already trained, that you can go up there, it's going to recognize cows, it's going to recognize general stuff that it knows and it ingests. But if you want it to be a little more specific, there's another API that can do that for you.
Sure. So Microsoft has come up with Custom Vision API. And Custom Vision API, where you can train your own models as compared to using the models which come with the built-in model. So the built-in world is actually well-trained. We know what a table looks like. We know what a raccoon looks like. There's also a large celebrity database available on cognitive services where you upload a picture of a celebrity. It will be able to identify that celebrity. They have about 200,000 different celebrities in there. Unfortunately, I'm not in there. I'm working on getting there. But it can identify different company executives and everything. But what if you want to build a database of pictures of your own coworkers and then being able to tag them in the pictures? What if you want to build a specific data set for your own products and being able to identify those in images? For that, Microsoft has released a Custom Vision API. It was long in the making. Now it's available for us to show, and I'll show you as a part of the demo as how you can actually use it. How many of you are Silicon Valley fans? That show, HBO show. So everybody knows about hot dog, not hot dog problem, right? That's a great problem to work on. So what I've done is I have created a data set from that problem. So here you will see. So hot dog, not hot dog problem, for those who don't watch Silicon Valley, is an image recognition problem where you have to differentiate between an image of a hot dog and everything else. So let's see. So I downloaded a large repository of images where there's hot dog pictures, not to endorse any specific brand, but essentially just the training data set. And then the random data set, which is every picture which does not have hot dog. It may have cats in there.
Now, how many images do you need for this? Like, what's a good...
So that's a great question. So data is the new oil, and the more images you have, the more training data you have, it's good. But you can start as small of a data set as 25. Right? So 25 images of the similar pictures will work. Now, the accuracy will increase as the more diversity comes in there. And those of you who are familiar with how the convolutional neural networks work, the strength of the network will be based on, and the confidence of the network will be based on how much data is there, right? There is no right answer. It depends on the diversity of the images. It depends on the bias, the variance, the accuracy, and the precision, and the recall, how you put that in there, and what are you trying to detect. But you can start this problem with about 25 images. Like that's the beauty of computer vision API, that you can start with really small data set. And it works really well. I mean, you will be just surprised if you start working with that. So let's go ahead. custom vision. So you will just go to customvision.ai here. And saving everybody time here, I already uploaded the data set here. Otherwise, you will just go to new project. You will call it hot dog demo. And you can probably make it categorized under the food category. And this is a live demo. What could possibly go wrong? Create project. All right. So you come up with this. You can add images. So you can now you go ahead and browse the local file. So you will upload the images you have from your data set, right? So you upload those images. It will add the images in there, and then you tag images. So let me just add this in here. I would, for the sake of test data set, I have a few images. I uploaded over here, and I'll say not hot dogs. All right, upload 3 files. And you can have tags, which are multiple different tags associated with each image. So this is like manual tagging. This is data creation, and is a big problem in machine learning, where you have to have this labeled data set available. People use crowdsourcing. People use Mechanical Turk. There are various different ways of handling this problem. But interestingly enough, computer vision API also help you in that case, because it can identify things in there, and it can help you generate those tags and those training data set. So if you want to create training data set, Cognitive API is your friend. So the images are uploaded successfully. Again, no cat was harmed in making of this. So here you have the tags for non-hot dogs. I can go ahead and click on train. It at least have 2 tags and 5 images for each tag. I just uploaded a smaller data set, but I have a larger data set available, which I'll switch to right now. In this case, I had a large data set. So if I look at general images here, these are all the general non-hot dog images. Then I have these 2 sets, which is essentially identical. And these are all the hot dog images, okay? And I click on train. Training was already done when I uploaded these images up there. Like, it's fairly simple. You saw how uploading was done. I can do a quick test over here. So this quick test can be done 2 ways. One is you can actually upload an image, and it will test against it. Second, you can do it via code. Let's take a look at both, how you would do that. So let's go to quick test. Let's browse a file. I'm going to pick up the cat hot dog and then see. So the probability of this being general is high, and being hot dog is low, 0.5. So you can see that it recognized that even though cat is dressed as a hot dog, it's not really a hot dog. Similarly, I can try with dog here. Let's see, try to fool this algorithm, see if it thinks it's a hot dog. It's running the confidence interval in the back. Oh, it came back. So it thinks it's a hot dog. So I was able to fool the API. And general is 0%. So it seems like, I guess it might be the dog aspect of the hot dog. It's getting dark. And actual hot dog, uploading that. Now this, of course, will be in the higher category of 100% hot dog, and general 0%. That means it's definitely a hot dog. So you saw how this API can easily be used to train and to be able to upload images and be able to test. And this is all the training images I had over here. And you can easily perform a quick test. Similar thing you can do with code. So fairly simple. I'll quickly show you in the code. So here's the custom vision API. Okay. I go ahead and I create a training key. You get the training key here when I try to create the, I'm sorry. You can get the training key out of here. I just am backing out. Yeah, here it is. I'm sorry. It was in the settings. Subscription key. So there's a training key right here, and there's a prediction key. And you can use your training key in the code over here. So you call get training key, and get training key essentially is looks at your training key, and assign the training key to your, create an instance of the training, and then takes the training credentials for you using the training key. And then you can use that to actually add the prediction key in there, create a memory stream for an image I have, and then use it to predict the image category. So this is the same thing we have just done. You can also do the same thing in Postman. You can create the API right like this and get the responses back, which it gives you a confidence interval of how, if this is an image of a dog or not. So this was a simple demo where we uploaded a bunch of images of hot dogs and then be able to predict whether this is a image of a hot dog or not hot dog. You can apply this to a wide variety of algorithms again, a wide variety of use cases in your case. So this is the custom vision API where it gets used. Yes?
So your application is for general purpose. It's not tied to hot dog, right? You can use it for anything.
Yes, yes. It can be used for anything. Custom vision API, so here, if you can create a new project and upload any type of images, like I showed earlier, any category of images, you can, so for example, if you want to classify between your coworkers versus other coworkers, or a set of boxes versus other set of boxes, or a set of products versus a different category, you can upload that category of images and then compare and contrast against that. So dog versus cat, that used to be the classical machine learning problem for the longest time. Now you can just do it with this API in like 2 minutes. Does that answer your question? The question was, is this specific to hot dogs? Then no, it is not specific to hot dogs. This can be applied anywhere.
Yeah, I think there's an app out there, is it bacon or not bacon? And the difficulty with that is it also recognizes Kevin Bacon as bacon. But I think they trained that in. Now, we were talking earlier, excuse me, we were talking earlier and you said you were doing some really interesting things in your company with this in grocery stores and stuff. Did you want to tell them about that? I like to talk about use cases.
Sure. This is a good use case for computer vision API where what happens is if you have a shopping cart, that's my pretend shopping cart, as you can see, and I'm walking out of the store at the checkout counter, Dan cannot see my cart, and he cannot see what's underneath the cart. So if I am forgetfully put a water pellet underneath my cart, and I forget about it, stores lose millions of dollars by this kind of forgotten merchandise. Forgotten, as you can see in the air quotes. So
and they have those mirrors, right? But you got to train the cashiers to really look in those mirrors all the time, right?
Exactly. Yeah. So in this case, what if a cashier get a notification that there is something underneath it? So make sure you check it, and also make sure that it's not catching up if a person is standing over there. It actually does object detection. It doesn't look at things like if there's a kid who's walking around there or somebody is just standing there. So having real object detection with good confidence interval and using that to notify the cashier that there is actually an object underneath it. So that's what we built. It is able to detect the object, and it is able to notify the cashier that there is something underneath it, and can you please make sure that you check that. So as soon as the cashier says OK, that means he has validated and has scanned it, then that thing goes away. It's a simple application, but it saves companies millions of dollars if you're implementing that kind of in a large retail chain, or if we implement it for large retail chain in Texas, but there is a bunch of different use cases where you can apply that.
So do you train it on what the cart's supposed to look like, and then if it doesn't look like that, or?
So the training data is essentially the cart with, so it's a classification. The easiest one would be the binary classification. You can do a multivariate classification. The binary classification would be when you have carts with just full carts, and then the carts where the carts have objects underneath it. And when objects underneath it could be the water bottles or could be other type of merchandise which you put underneath it. And that was our classification data. It wasn't that large either. We have about 10,000 data sets, and those images are available because the store takes those images. So we have those images available for the carts from various different dimensions and from various different pictures, besides from different angles of the images. So this is a very great use case. There's one use case we have implemented, which I was talking about industry is, for example, this bottle has text printed over here. Right? You will be surprised how many companies don't actually get the nutritional value and other information. When I say companies, it's retail companies. They don't get this information out from the vendors who are making this. So how many calories are in this water, for example, or other nutritional value information from the water. So high-resolution images of these products are available, and you can apply OCR on top of it and get that information out. However, you cannot do it with products like water bottles or the things which have contours on it. So there is another library available from Microsoft called CNTK. There's a cognitive toolkit, which is essentially everything underneath the Vision API and the Cognitive Services API. All the engine behind it is called CNTK. And I think there was a talk around CNTK as well. So that is an amazing library, which allows you to do resolution for contour and apply advanced OCR, where you can use Keras, there's another open source library, with CNTK to figure out what text looks like. So for example, if you have cosmetic bottles, have you seen cosmetic bottles? They have like weird contours, and the text kind of dissolves into the bottle itself. So we use CNTK and Keras to be able to figure out that text, fill out those details, and provide that inventory details over to the retailer so they can actually add these values. Now, these are real-world use cases with like a lot of different implementations and so implications, large implications. So, I mean, we can talk about this all day long. But just to sum it up, cognitive services are a really great way for you to get started within your company to start applying machine learning within the enterprise without knowing, building an entire ecosystem for that, without getting GPUs up and running.
Yeah, that's actually a good segue. One of the things that I like is most of these cognitive services have an extra step, just like we talked about the vision, how you could use, to find a cat or a raccoon or whatever with the basic one. If you need to dive deeper, you can use that. There's one for speech. We just talked about CNTK for, using it for OCR. One of the things there's a lot of stuff under the computer vision API. We looked at, what this would do, but OCRing and reading text images. This isn't just, we've been doing, if you've been in the industry for a while, you've been doing OCR forever, but it's usually on PDF or, flat text documents. This is a much bigger, denser way to read OCR. It looks at all different types of fonts. It doesn't have to be, straight on. It can be sideways, and it can capture stuff really nice for different purposes. Another thing that I really like, this is relatively new, is handwriting recognition. If you're thinking about OCR and trying to do it with handwriting, it's incredible what this can do to recognize handwriting. Now, it still has trouble with my handwriting, quite honestly, but I have trouble with my handwriting. But if it's handwriting that's relatively clean, it's pretty good. Do you want to show something?
Yeah, I want to show something. So once you get a PhD, every meeting you have is a doctor's appointment. I'm sure you have heard of that. So you can actually get like a doctor's note and then say that. Second thing is your handwriting, nobody cares. So I'm OK with it. But for sentiment analysis, you saw in the earlier keynote demo, there was a sentiment analysis piece of it. I don't know if you catch it quite, but there was a bot framework when a person was talking to the bot, and he was saying, I don't like, this is too expensive. And all of a sudden, you saw an agent jump in during a conversation. How are they able to do it, and how can you do it in your application? So for example, you have a CRM application or a chatbot internally, and you see a customer getting frustrated. Another application, great application for sentiment analysis, which we did, is figuring out from Twitter feed for a brand how customers are reacting to that brand, right? So for example, a large company releases a cool product, and I'm trying to refrain from using names. And then they want to figure out if it goes viral or if it is like a terrible service. So a telephone company had a terrible service in a certain area. Now with demographic targeting, you can figure out from their Twitter feed where they are located and then be proactive about it. Now, of course, you can't keep up with this Twitter fire hose. So you need to use these APIs. So this is where the sentiment analysis API comes into play. So like Microsoft Cognitive Services has the text analytics capabilities here. So here it says, I have a wonderful experience. The room wonderful and staff was helpful. This session is awesome. I am learning a lot, right? So here I can say, and it's going to analyze this text. It can also analyze the language. So you can actually see JSON right here. That's what you were seeing earlier. Remember how the language was being switched when he says bonjour, and then it changed to French, and then so you can actually see that happening over here as well. and get this JSON. This is live. This is actually making an API call, and it typed it in there. And it analyzes the text and says 88% sentiment is there. However, it has problem detecting sarcasm. So if I'll say, yeah, not, this session is awesome. I'm learning a lot, not. You analyze it, and it still thinks that, it's OK. So we are working on that to make this sarcasm text. But you can actually, it uses topic modeling. It uses keywords. So it will say, this session can use a lot of improvement. I was expecting a bigger raccoon and a rabbit. I'm sorry. Apparently I don't know how to spell raccoon. OK.
He's still right here and sitting in the front row.
OK, so here it is. The sentiment is 78%, and you can see this. This is horrible. And now you'll see how the sentiment has changed to 24%, and it is there.
Yeah, so you were talking about signatures. We just went through the purchasing a house again, and the guy came over, the notary, to sign. And the lenders are really weird about your signature matching on every single page. And so he said, just make it as messy as possible. Then they don't care. So it's really weird. So my normal signature is messy. The ones on the documents are like just a scribble line. So one of the things I like about cognitive services is how easy it is for you to test, too. So you've seen him do some. I'm showing you some here. It's one of the places where it's really easy for you to take your data. You're like, I think I want to do this with my app. You don't have to go get a key. You don't have to really do anything. If you have images you're testing or you're OCRing or whatever, you can go to Microsoft.com Cognitive, and then I went down into Vision and test all this stuff. So Vision has recognized celebrities. I know you said you're trying to get on that list, but you're not there yet. Analyzing video in real time. This one seems like the simplest thing in the world, but it's fascinating to me. How many of you have ever had to create thumbnails for any kind of application you've ever built in your career? It's painful, right? So you know the size, but the size doesn't do anything for you. So you crop it to a certain size because you need a thumbnail for this section or that section or whatever. What this does is it takes it and looks at it and says, I think this is the focus of the image. And that's where you're going to crop it, right? Seems very simplistic, but it uses that kind of computer vision to determine what it thinks is the focus, and will crop it right around that. So let's go back now to so let's talk.
You need to turn off your camera for the second demo.
Oh, yeah, you're right. So next, let's talk about the face APIs. We've seen a little bit of what it can do just in the Vision APIs, but the face APIs allow you to do detection, verification, grouping, and identification. And what you basically do is upload the image to the service, and it'll give you back a ton of data. You can see that it thinks I'm 9 years younger than I actually am. You can tell that it gives you the face rectangle. So one of the interesting things is when I've done this talk before, believe it or not, I used to have hair. And so it doesn't matter if I have hair or not, because what it's checking is the rectangle around the face. And it marks different places on your face. Obviously, the pupils, the ends of the eyes, eyebrows, nose, corners of the mouth. And then it saves that data. It also, you can see that it'll look at the head pose. Because when you've done this stuff before, you had to be like straight on and make sure you were exactly in the right place. Otherwise, it wouldn't recognize. But it looks at the roll, the yaw, and the pitch. And so it does calculations to be able to tell. Once it's saved a face, it's able to tell if it's mine or not when it checks again, because these things over your lifetime, at least your adult lifetime, are not going to change that much. You know, when I put a picture of me as a child, and now it doesn't think it's me, and it shouldn't, because hopefully my head grew a little bit, right? But you can see the landmarks, the things like, it'll tell you if you're wearing glasses, you know, your age, all that other stuff. I think I have more information on the next page as well. And it basically plots it out. And so after it does that, there's a bunch of things you can do with it. You can give it 2 faces and say, is this person? And one of the things we've done with this, we built this was a hackathon project, but we built a monitoring system for a club. So when people would come in, they would pass by this camera. It would, again, give you the relative age of the people that are coming in the club, you know, male, female, the demographics of what's going on, but it also would match their face. And so if they were a VIP, it would automatically say, hey, welcome, and the manager would come over. It would tweet out on their Twitter account that, hey, so-and-so VIP's in the club, you know, come by and join him. And then the other side of it were band people. So as band people were coming in, it would, you know, say, hey, nope, you got to get out of here. So it was able to track them and see it and know that it was going. So that was one use case we did.
So that's where I would like to add a couple of things. The machine learning researcher and myself would like to talk about this thing called transitional variance. So when you are looking for an image or looking for an object within an image, there used to be this idea like you will have to traverse through the image and do this. This research has made leap and bounds like a really huge impact in the academia after they came up with the concept of transitional invariance, which means you can have objects available in any part of the image, and it will be able to detect. In a nutshell, the way it works is, have you heard of this linear algebra term? I know it's probably like high school algebra a long time ago. You probably have heard of this thing, eigenvectors. So these images are not necessarily stored as these images in the model. When we say model, it's a machine learning model. It doesn't store these images as is. So you shouldn't worry too much about your picture being uploaded somewhere on Microsoft servers or any other servers, but rather it gets converted into a matrix, 8 by 8 or 12 by 12 matrix, and that's where it actually gets matched against. And the accuracy is really good. And recently you probably have seen when the twins were trying to do matching against each other and it wasn't able to detect. And Daniel has another example in the face API when his picture from various different ages doesn't change. So the algorithms are really accurate, but just to re-emphasize on that idea of transitional invariance, it means it doesn't necessarily look for specific points within the image. It applies it to the entire image, and then it finds out those data points, because the algorithm has to be really, really fast to do it real time.
Yeah, and it's, you know, one of the things the Face API can determine is, you know, whether you're wearing glasses or not, and whether you have facial hair, et cetera. One of the things that you will have a little difficulty in is, you noticed for whether you use the Uber thing next door, it wants to see your eyes, right? So whether you're using glasses, sunglasses, or even glasses that are reflective, it doesn't like that. It wants to see where your pupils are, right? It's a very key point of what it's graphing. Another thing you can do, we did this, is clustering by people. You've seen this for years and years now. If whatever photo upload thing you use, I can find all the pictures of my kids just by clicking on their face, and it finds them all together and groups them. So it's a really cool use case to very easily find pictures. It's something used every day. But I like this one. So one of the things that is interesting at many companies is you have secure areas and not secure areas, right? And a lot of times you just have your badge to beep in, and you know that keeps it relatively secure, but it's not very hard. We've all seen those spy movies, right, where they just walk by and Matt Damon just grabs the badge and he's gone, right? And so he can now get in back at the casino and all that other stuff. What you can do with this is have a group of people. So you run the Face API on a bunch of people, you put them in a group called colleagues or whatever you want to do, and then you can use that to have them gain access. Gain access to, it could be a door, but you can gain access to a screen on a computer, or being able to sign on somewhere, or get into a website, or whatever it is. You can now use that face recognition to get there. Oh, you look like you wanted to add something to that. No, okay. So one of the things, actually I was going to tell you a story, but I'll wait. So one of the second things we'll talk about is speaker recognition. So it's it goes hand in hand with the face recognition. One of the problems with the base cognitive services is, I can hold a picture up and kind of fool it, because as opposed to like Windows 10 where it's kind of doing a 3D image, you can't do that. With this API, you can. So I like to pair it with speaker recognition. And so for speaker recognition, there's two phases for it. There's enrollment, and then there's recognition. And with that, you can do speaker verification or speaker identification. Speaker identification is listen to this voice and speaking and tell me if it's President Clinton or whoever it is. Speaker verification is this is my voice, right? My voice has very unique characteristics, and you can plot that just like you can your face. Yeah, sure. Yeah, jump over and show it.
All right. So there's this live demo available on Microsoft site, and this is a really cool use case, but please don't use it. All those long conference calls we all sit on, and we are like, oh my God, and then there's somebody calls your name, and you have to jump up and then figure out what was the question, and then you have to answer, and then you'll say, can you please repeat that question? I think we all have been on those conference calls. So this is where you can use this transcription API, where it recognizes the voice, and it recognizes, you can train it on your boss's voice. None of this is a recommendation, by the way. So here in this case, for example, I'm going to play audio.
Over fear. Unity of purpose over conflict and discord. On this day, we come to proclaim an end to the petty grievances and false promises, the recriminations and worn-out dogmas that for far too long have strangled our politics.
So it was able to recognize the voice, and you can actually get the JSON output right here. The response. You can also train your own audio samples by putting this different audio. So you can start recording. I can record my voice, and then it will be able to recognize who is speaking at that point of time. And so in a conference call, if you want to transcribe the conference call based on who was speaking, you can take some of the audio samples from, for example, Dan, and then use it to train the model. And after that, you can put a large audio file here, and then it will transcribe and cut out the pieces based on what Daniel said, because you think that was some important part. And then it will cut it out, and then you can apply the same cognitive services for transcribing that audio into text, and then read what was being said. And you can automate that entire process. Switch to.
So, like I said earlier, I like to make things personal when I work with this technology. That's not it. Well, that's me. So I guess that is kind of personal. And so to me, there's like really cool, fun things you can do with it. Obviously, if you know where everything is on my face, and that's me at, I don't know, probably 7, 8, I can place a mustache under me. Or, you can do stuff like the howl.net. I'm sure everyone's seen this by using the Face API. Or Project Murphy, which is, really cool, like what would I look like with a beard, and it'll, place a beard on you and stuff like that. But I like to make it a little more personal. So I have a video for you here. That's me on a bad day. So having two little kids, I have a 4-year-old and a 5-year-old, I was quite surprised actually when they started going to, my daughter's now in kindergarten, but when they started going to preschool, that the way you sign in and sign them out is on a piece of paper. Like, we're still in the 70s. It's not secure if you, and, you start going to the gym and, there's a kids club and gym. That's completely unsecure. You go to anywhere and it's unsecure. I'm like, this is crazy. And so I thought, well, I should build something that, can kind of take care of that. And these services really help that. So let me go ahead and show you what I built. Let me go ahead and run it first, and then we could look at the code after.
Then you need ReSharper.
I know.
No endorsement, but it's pretty cool.
So that's my daughter, and I can select her and put her up there. Oh. Uh-oh.
Escape.
My daughter will be so upset.
I'm sure.
Did you already pull this out and put it back in?
Sure.
Jeremy, does this look familiar?
This is called demo syndrome.
Yeah.
It happens every time. No, I think something wrong with that. Okay, that's my screen.
This is. Here we go.
No,
Maybe.
Okay. We have it.
Okay, let's see if this kills it. And if it kills it, I guess you won't be able to see it run. You got it now? Okay. So here's my daughter. And I can select her, bring her up. If my son's right here, being goofy like he always is, I can choose him too. They were at the same school for a while, but he's not there now. So I'm going to remove him. And I can check out child. And so that's being weird, but I can try and verify. 57%, so it does see me as the same person. The lighting's kind of strange and stuff. So once I'm able to verify my face, I can verify voice. We'll see how this works. So the first thing you need to do is enroll. I've already done the enrolling. And what you do in the enrolling is it has a certain list of phrases you can use. And so it's much easier to train on specific phrases, and maybe you can talk more about why they do that later. But I chose a phrase, and I recorded my voice 3 times, and you can see what it was. My name is unknown to you. And once I do that, and once I train it at least 3 times, then I can go ahead and use it. The more you train it, the better it's going to be. So what I would do is do record. My name is unknown to you. It recognized my voice, and now I can check her out and I can go home. So this would be on a big board. Before I walked out, they were able to see that, Zoe's able to leave and everything's good. And it's relatively simple. So here's all the phrases so you can see them. I'm not going to run through it because it's just me saying the phrase 3 times. But you get to choose your phrases from the list that they have. And the implementation of it's relatively simple. So a lot of this code is just grabbing the image and saving the image down. We're not going to go through that. You can see I have my subscription key, which I'll have to change because we're on video in here. I need to initialize a few things. I'm initializing a combo box because the combo box on the page is going through the number of cameras that I have on. I'm creating a collection because what I'm doing is I'm capturing the face ID of the picture I have on file, which was what you saw on the left, and then my recent one, and then I'm going to compare the two face IDs by going through that collection. What I want to show you, though, is here's starting the camera and stopping the camera. Where is it? So this is the check for face. So in check for face, I'm reading the image, and I'm calling, this is just where I call the service. It's the face service client, and I pass in the subscription key. I tell it what I want to come back. I want the face attributes of age, gender, smile, whether I'm smiling or not, facial hair, head pose, and glasses. And then I do detect. So it says, is there a face in there? And if it is, it returns a face ID. The other thing it does down here is then, after it's detected both the picture and me, it will compare faces. And it's the same thing. I'm passing in the face IDs that I got when I sent it away, and then I call the face, I create a face service client with the subscription key, and then I just do a verify a sync. And that's what you saw coming back with the confidence level and everything else. Yep.
Does this support the reading camera? You know, like iPhone X, they come with a better camera. And generate the image, probably generate.
Does it support it or utilize it? So I believe it supports it, be able to take it, but it doesn't utilize, this API does not utilize the 3D. Does that make sense? Like, I can sign on to my Windows machine the same way. It has that 3D rendering that it checks, but the Face API does not utilize that. Yeah.
So one of the homework, you didn't know that you're going to get a homework when you come here. Over the weekend, it could make a really good project where you can make a face recognition doorbell and put Nest out of business. So imagine, like it's a simple, takes a Raspberry Pi, you can run and then make an API calls to cognitive API, and then recognize the faces of the people who frequently visit you. And that you can use to find out different kind of faces. The same thing he did, go through the enumeration of the faces you have, recognize, and then even have a custom greeting. Send out, hello, welcome Mr. X to Casa di Dan. That would be really creepy and really cool.
I don't know if it'd be creepy. So yeah, so there's a ton of stuff for you to do, and like I said at the beginning, it's very additive. So hopefully, whatever industry you're in and whatever projects you're working on, you could think how you can use these APIs to make your application just that little bit cooler, a little bit funner. Funner is not a word, is it?
I don't know, you just made it up. It's funner.
Yeah.
Funner is the word. But think about the business implementations of this. So we can make a Nest Bell, and that would be really useful. But one of the demos which was demonstrated earlier in Ignite, where you have a warehouse. And warehouse has certain different type of instruments which people can use. So for example, there's a jackhammer. People are not going to trust me with a jackhammer, but might be like a screwdriver I can be trusted with. So by using computer vision API and the face API, you can actually audit what kind of instruments are getting used by which person. And this is not like a science fiction thing. This is actually being implemented today, where you can actually assign a product or a specific instrument to a person saying, jackhammer can only be used by this person. And then if somebody else, and the real-time cameras are actually monitoring that person, and then it can track. We have video indexer and video API. Short of time, I don't think we can demo that. But it can detect it, and if a person who is not authorized to use jackhammer starts touching the jackhammer, it triggers a fault. It triggers an alarm and a warning, which will tell people. So you can use that kind of applications across an industry in tons of different places, from making sure your buses for school are in good condition. So you train a model for how a bus looks like, and it is not faulty, and the tires are in the right pressure, and it looks like its windshield is intact. And then you can use IoT sensors along with it to do a automated checklist of a school bus to make sure it is in fit condition to go, instead of relying on manual techniques. So when it comes to business use cases of computer vision, there's like tons of them. And in your industry, whichever vertical you work with, from healthcare to retail to sales and marketing to anything you can imagine, AI and machine learning, and especially computer vision, is highly useful.
Yeah, so I know we were a little silly in parts of it, but I hope you guys learned something and enjoyed the presentation. We were happy to be here, and thanks for coming. And for those of you, we do have a few minutes. While we're tearing down, you can come up and ask questions. We're happy to answer any questions you have.